All right, guys, today we get into exponential graphs, and these are not too bad. Learning target, I can determine if an exponential function is growth or decay by examining the base, and I can graph an exponential function. This is going to relate to the M&M lab that we did yesterday. So what is an exponential function? It's a function where the exponent is the variable. Okay, so it's not y equals mx plus b anymore. For exponential, you have y equals some number and the x is the power. Okay, that would be an exponential function. It's going to be an exponential growth if the base is greater than 1, and it's going to be a decay if the base is less than 1. But something to note, they always have to be positive. They always have to be bigger than 0. So they can't be 0 and they can't be negative. Okay, so an example of an exponential growth, a number bigger than 1 could be like 2. All right, so y equals 2 to the x power, that would be a growth because 2 is bigger than 1. Decay, to get a number less than 1 but not negative, it would have to be a fraction. So maybe like 1/3 to the x power. That would be a decay. And then something that exponential graphs always have is something called an asymptote. And it's a line that a function curves toward but never actually crosses. And I will give you guys an example of that. Oh, I could just do it here. So let's say from your M&M lab, you guys remember that your graph looked like that, maybe for the growth. It never actually crosses 0. That's called an asymptote. So you'll never see it dip down there. Okay, so let's try a couple. You guys just look at this and tell me if it's a growth or a decay. And it's all based on this number. Is it bigger than 1 or smaller than 1? All right, now 4 is bigger than 1, so it is a growth. 2/3 is smaller than 1, so it's a decay. 2.12 is bigger than 1, so it's a growth. And 0.2 is smaller than 1, so it's a decay. All right, and now we're going to go into how to graph these. So to graph an exponential function, first thing you do is make a table of values. So you make like an XY table. So you plug numbers in for x into the function in order to get y. Okay, you've done that before. Then you're going to use the value, use the table of values to plot points on the graph. You've done that before. Then you're going to draw in the asymptote. And for all of our problems, it's always going to be at 0. So you're always going to have an imaginary line at 0 that the graph will never cross. Oh, here. And then lastly, draw a curve to connect the points. All right, so this isn't going to be too bad. All right, number 1. First of all, if it's y equals 3 to the x power, is it going to be a growth or a decay? Well, this is bigger than 1, so it's going to be a growth. All right, and now you guys, for the rest of this, go ahead and pull out your calculators, and we're going to plug these numbers in. Okay, so when x is -2, what's 3 raised to the -2 power? You get 0.1 repeating. Okay, what's 3 raised to the -1 power? That's 0.3 repeating. What's 3 raised to the 0 power? That's 1. 3 raised to the 1 power is 3. And 3 raised to the second power is 9. Okay, so you start by making a table of values. All right, and then use that table to plot these points on the graph. So these are just ordered pairs. And I know that the decimal ones are going to be a little weird. So negative 2 comma 0.1 is like really short there. Negative 1 comma 0.3 is just a little bit higher. 0 comma 1 is here. 1 comma 3 is here. And 2 comma 9 is here. Okay? Always make a asymptote, which is a line through 0. That means the graph can never cross 0. And then if you connect the dots, try to make it like a nice smooth curve with arrows on the end. And that's your first exponential growth. All right, let's try decay. So, number 2. Start, first of all, is it going to be a growth or a decay if the base is 1/2? Well, 1/2 is smaller than 1, so decay. All right, bust out your calculator and plug in all of these points for x. So it's going to be the fraction 1/2. All right, first we're raising it to the negative 2 power. So raised to the negative 2, you end up getting 4. Then we do 1/2 raised to the negative 1 power, and you'll get 2. And then we'll do 1/2 raised to the 0 power. Well, you guys know anything to the 0 power is 1, so you don't have to do that. Then we got 1/2. Some of these you guys don't have to use the calculator for. Raised to the 1 power. Well, anything to the 1 power is itself, so that's still just 1/2. And now 1/2 raised to the 2 power. That's going to be 1/4. Okay, let's do it. So plot these as ordered pairs. So x, y, x, y, x, y, x, y, x, y, and this should be a decay. So negative 2 comma 4, negative 1 comma 2, 0 comma 1, 1 comma halfway up, and 2 comma only 1/4 of the way up. Something like that. Remember, there's always a asymptote at 0, meaning you can never cross 0. And then if you connect the dots with a smooth curve, this would be a nice decay. All right, I'm going to leave you guys with that. There is a third one, but it's the same thing. Just plug in the numbers, get your graph. All right, nice job, guys. That is graph day 1.